Hi, this is Dr. Weber, and I just wanted to go over how we use Excel to plot everything for experiment 3. Everyone's going to get unique data for them, and through LabFlow, it'll look something like this. They're going to give you two different cooling curve values, and you're supposed to plot them into Excel. So here I have my cooling curve 1, and then I created a separate data sheet using this little plus function, and I put cooling curve 2's data. So cooling curve 2, cooling curve 1. You can certainly use it all on the same page, but I'm just trying to stay organized. I also wanted to make sure that I'm labeling everything just because I want to make sure I know which one's going to be my x-axis and which one's going to be my y. Normally, when I'm plotting in Excel, I like to put the x-axis on the left-hand side and the y-axis on the right. This is all adjustable in the end, but it's just what I prefer. I'm going to highlight the data points that I want to put in my first cooling curve and then go to Insert, and I'm going to pick the XY scatter plot. It's going to look something like this. I can make this look really nice, zoom in on things. It would be best if you did that. So the title is going to be the first cooling curve. I can also use add chart elements. The x-axis is going to be time. And it's really important for you to include units. The y-axis is going to be temperature. And that's going to be in degrees Celsius. So you can do two things. You could just write it out degrees Celsius, or you can go to Insert, and there should be a little symbol button, and then you could find the degrees there. So that's how I would normally do it, but let's just go over how to do the math on everything. So I can't really see the cooling curve here, so what I'm going to do is I'm going to zoom in on this y-axis so I can see it a little bit more clearly. So if I just double hit on here, I'm going to be able to use the axis options and then this little bar portion. And I'm going to change the minimum to, I think, a 65 and the maximum to a 90. Perfect. Now it's more zoomed in and I can clearly see the cooling portion of this curve. The next step is to plot the trend line of the cooling portion of the curve. But if I plot the trend line as the way it is, it's not going to be very accurate. So I need to figure out where my stopping point is. So if I want to figure out where this cooling portion ends, I'm going to have to estimate around here what temperature is the last point and make a new Excel plot. So I'm going to remove this trend line and I'm going to hover my little mouse over where I think. So this is a relatively straight line where it starts curving out maybe around right here. So I'm going to say the last point is going to be 450 seconds, 450 seconds. So if I go here and I re-highlight up until 450 and I make a new plot, so Insert, Plot, now I have a relative straight line. So let's do, let's name this first cooling portion. And the X and Y axis are going to be the same. I'm going to have to adjust this. So let's go to 65 to 90. See, that looks like a much more linear graph. So the trend line is going to be much more accurate. Let's add our X and Y axes, horizontal. Whoops. Horizontal is going to be time. I don't know what happened to this bottom portion. I'll figure that out. And then we have temperature. And degrees Celsius. I'm just going to put a C because right now I don't have the other one. And it looks like I lost my Y or X axis. So I'm going to make sure that I have the axes. Let's put that horizontal back. Okay, much better. Let's add that trend line. So down here I can click trend line. That looks so much better. Let's figure out what Let me go trend line and then more options. It's linear and I want to see the equation. Let's see the r squared. So the r squared is pretty good. Anything that is close to 1 is a good r squared value. That shows you the linearity of that line. And then this is going to be our equation that we're going to be using for our lab report in LabFlow. So when it says what is your y-axis, it's going to be this number. Our slope is here. And now you can continue on with everything else.